Hi, this is Mr. Beckstrom, and today I want to take a look at a problem from section 3.2. This is on building linear models from data. And we want to find an equation of a line that is using these 2 points here. So it's going through those 2 points. So the first thing I like to do a lot of the times is just kind of get an idea of what this line is going to look like before I do it. So if I go and I kind of graph this here, oh, that was a horrible horizontal line, but something like this. I don't have to be exact. I just kind of want to get an idea of whether the slope is going to be positive or negative, and whether it's going to be kind of steep or gradient. All right. So the first one is 3, 2. So if I go out 3 and 2, I'm going to have a point like right around here. And then 7, negative 11. So that's going to go out further, way down here. So it's going to be something that looks kind of like this. So it's going to be a pretty steep slope, and it's going to be negative because it goes from the upper left to the lower right. And this is more of just a kind of a check at the end to make sure that it fits this this criteria. All right, so in order to do this, oh, and we want to put the final equation in slope-intercept or y-intercept. The slope-intercept, y-intercept, the same thing in that form. But when we're given 2 points, the best form to start with is the point slope form. And that looks like this. It's y minus y1 is equal to m times x minus x1. Now, let's go through what these are. The x and the y, we're just going to keep as the x and the y. That's going to be the x and the y in our final equation. The x1 and the y1 are from one of the points. So you can either use the first point or the second point, depending on which one you choose as the first or the second. It doesn't matter. It'll come out the same. But just make sure you stay consistent throughout the problem. And the m is the slope. That's the slope of this line. So that's the rise over run. So if I call this point here my first point, and I call this point here my second point, then I have the x1 and the y1. The x1 will just be the 3, and the y1 will just be the 2. The x1 means take the x coordinate of the first equation. The y1 means take the y coordinate of the first equation. All right, but I still need to find that slope in order to process this problem, so I need to know how to find the slope. And to find a slope, we have a formula for that as well, and that is y2 minus y1 all divided by x2 minus x1. So here's where I'm actually going to need that second point there in order to find that slope. So if I plug in these values, so this is going to be my x1, y1, this will be my x2, y2. So my y2 is negative 11 minus my y1, which is 2, all over x2, that's the x coordinate from my second equation, which is 7, minus x1, which is the x value from my first equation, which is 3. So I'm going to get over here, that's going to be negative 13 over 4. I can just kind of leave it just like that. That's fine. Now I have everything I need in order to put it into the point slope form, and then we're going to solve for y, which will put it into the slope intercept form. All right, so going back to this first equation there, I'm going to have y minus y1. That's going to be, I could use this point too, like I said before, but I'm going to use this point. That's going to be minus my 2 is equal to m, which is negative 13 over 4 times x minus x1, which is 3. All right. And this is going to be, I'm going to go ahead. So y minus 2 is equal to, I'm going to distribute this. So this is negative 13 over 4x minus, and then it's going to be the 3 times that. Oh, minus times a minus, that's going to turn into a plus here. That's negative times a negative. And 3 times 13 is 39. So this is going to be 39 over 4, which is almost 10. I think that's 9 3/4 if we were to turn that to a whole number. And the last thing I want to do is I want to add 2 to both sides. So y is equal to negative 13 over 4x plus the 39 over 4. And then I want to add 2, but I want to add it in such a way that it has a common denominator with this fraction. So I'm going to write that as 8 over 4 because 8 over 4 is also equal to 2. It's the same thing as adding 2 to both sides, but then I can combine those fractions to give my final answer of negative 13 over 4x plus should be 47 over 4. That's it. If you have any questions, just let me know. You can always put this in your graphing calculator and make sure it looks like that or similar to that. All right, and thank you. Have a great day.